Okay. Hopefully we're live and the broadcast is running. Yeah, it looks like it's going. Okay. Thank you, everybody, for coming along to the last of the Enhancement Week talks today. My name's James. Some of you probably know me already. I'm Program Leader for Computer Science. And today I'm very happy to host a good friend of mine who is joining us today from London to talk a little bit about his work at The Guardian. So this is Michael Barton. Michael Barton's currently a senior software developer, lead engineer, in fact, at Lego, but was previously a senior software developer at The Guardian. And he's done a lot of interesting work over the last few years in the area of investigative journalism. And that's going to be the focus of his talk today. If you have any questions at any point, if you're physically attending this talk, feel free to let Kieran know and he will post this question. If you're watching remotely, feel free to drop a question in and I will pass it over to Mike along the way. So without further ado, I will hand you over to Mike to talk about his work from The Guardian. Over to you, Mike.
Thanks, James. Hi, everyone. Thanks for having me. Thanks for joining both virtually and in person. Today, we're going to be talking about how computer science is powering investigative journalism, which is a fun title and a slight fake out to James because we're going to talk a lot about how computer science is powering investigative journalism. But we're also mostly going to talk about collaboration, I think, and what I learned about collaboration and building software sort of in collaboration with users as part of doing this work. But before we dive too deeply into it, I'll just give you a quick intro. So as James said, I'm currently a lead engineer at the Lego group. We're not really going to talk about Lego today, which might be a shame depending on if you're a fan or not, but we're definitely going to talk about the work I was doing previously at The Guardian. So just to kind of give you some context, The Guardian is a newspaper in the UK, America, Australia, and online, sort of across the world. And there's what they call the product and engineering department, which is a bunch of software engineers building various things kind of across the gamut from, the sign-up pages all the way through to the back-end systems and some of the things that we built to help journalists, which we'll be talking about today. But first, before we get started with that, I thought I'd like to kind of take you back to my own university days. So I studied at the University of Birmingham and did computer science as my bachelor's course. And it was in the third year where you got to pick the project that you were going to do. So slightly over-ambitiously, I think, my project was all to do with audio analysis. So that big kind of ugly machine that I've got a picture of there is called a chaos pad. And back in the day, you could sort of plug in the audio into the back of it and the screen blinked with those kind of cool red lights and you could drag your finger around it and it would make the audio kind of do lots of different effects and different noises. It would go kind of all kind of fun noises that probably really don't translate through the microphone on a live stream. But I was interested in building a kind of computer emulation version of that and it roughly worked, but I had no idea what I was doing. And I got a lot of support from my supervisor for that project, who was a guy called Achim Jung. And midway through kind of the project, it was my third year, I was looking for places to get jobs. I knew I kind of wanted to move to London. So I'd interviewed at a place and got a job. They gave me an offer and I accepted. So when I went into the next kind of session with Achim, rather than, talk to him about the intricacies of trying to build filters and, how to model kind of analog sounding filters, I just said, guess what? I've got a job. And he went, oh, that's fantastic. I'm really happy for you, as you would expect your supervisor to be. And he said, oh, what job have you got? Where are you going to work? And I said, I'm going to work for, it was a company called ITRS. And they do kind of financial monitoring systems. So basically systems that run inside banks and that tells you when the computer systems have fallen over or when there's something that's wrong with the computer systems in banks. And Achim's response was, oh, no. Oh, really? What? And we sort of finished the session. And obviously, I went and started that job and everything. But for a long time afterwards, I was sort of slightly confused by his reaction. I wasn't really sure exactly what he meant. And over the course of this talk, we'll kind of think about that and, come back to it later. So moving forward several years, I joined The Guardian to work as a software engineer. So as I said, the Guardian, is an online newspaper. So there's the back-end teams who work on serving the web pages, the articles to users. Then there's also the teams who work on what are called kind of content management systems. So simply put, you type into a box that as a journalist, you type into a box, someone edits it, you click publish, and then it goes live on the website. And it's pretty common for these systems to be bought in. But The Guardian is weird and builds a lot of this stuff in-house. So I've included some screenshots of the in-house content management system, as it's known, called Composer. You can see there's this really cool thing, which is like a kind of internal Grammarly for the style guide for The Guardian and stuff. There's building really exciting things. And for about sort of 2 years, I was working as part of what was called the Editorial Tools team. And honestly, it was pretty thrilling. Like, you're working, to a newsroom where there's sort of a flow for the day, articles need to go out. We were trying to make the tools really usable. People were big fans of them, so people became like power users of it and might know a bit more about how it works than you do when you're programming it. But then you get to know them and you can start to build, kind of tools that not only kind of work for what they need to do, but are being improved in ways that are discussion with them, which is really exciting. And The Guardian has a whole suite of these, which was great to work on. And we sort of realized between me and some of the other kind of senior developers, people like Simon Hildrew and various others, that we were building a lot of world-class tools for producing the journalism. And what does that mean, kind of producing the journalism? Well, at the end of the day, it's typing into the box, adding some images, arranging things on a screen in the shape that you would expect, to see from a news article. And that's all kind of what's referred to as production. So in a similar way where, there'd be people who lay out things on a newspaper page, there's web tools at The Guardian to lay out things on the website. And we were building all of these fantastic tools where we would take stories. So journalists had done all of their work to produce the story, and then we take it and we would put it on the screen. We'd make sure that it had the right audience. We'd make sure that people were engaged with it, that we were reaching the right people, kind of all the analytics that go into that. But we realized that, maybe there was something that was not missing with this, but there was kind of a big piece of the pie that maybe we weren't quite covering. And the former director of engineering at The Guardian, a guy called Phil Wills, very succinctly kind of summed it up in one phrase, which was, as technical people, as programmers in this organization, we start when they finish. So journalists do all of the work to produce a story. They go out, they speak to sources, they dig through huge numbers of documents, they investigate, they probe, and they've got technology to help them, that they might sort of use, Excel spreadsheets or, translation things online, and all kind of, a lot of mix of sometimes free, sometimes paid for things. But we'd really had a laser focus on making fantastic production tools. But we'd never really gone into the detail of, what are journalists doing when they produce these stories? What kind of help do they need from, a technical point of view? And we knew that there were kind of this big missed opportunity, essentially, for building software that journalists were going to use in that kind of news gathering process for putting stories together. And to kind of give you context for, what that means kind of in the current news landscape, I guess, The Guardian was one of a sort of team of journalists who worked on the original Edward Snowden story. So for those who may be familiar, maybe not, that's Edward Snowden, that guy up there. I don't know where he is on the stream, about there. And he came to The Guardian and other media organizations with a number of documents that were talking about surveillance activities that the US government was doing essentially en masse on internet traffic across the world. And so these were documents. There was actually about 55,000 documents, I think, roughly. And so in this case, with quite a lot of secrecy, because they were pretty secret documents, the journalists had to go through them all and work out kind of what was newsworthy, because, Snowden could tell them, but it's not always up to the source in investigative journalism to tell you what the story is. They want to highlight it to you for a particular reason. But as a journalist, you have to go through and determine, motive, and maybe there's something in these documents that was missed. And it sort of didn't kind of kickstart this style of reporting, which is based on kind of data leaks. So lots of files come to you, and then you have to comb through the files to produce a story. So it didn't really kind of kickstart it, but for The Guardian, it was kind of the first example of that. And actually, you know, they bought a piece of software to just churn through the files and then kind of search it. And we'll talk a bit later on about kind of how that software works. But, you know, since then, there's been, you know, various investigations, you know, worldwide that have taken this kind of data leak driven form of journalism to new heights. So the Panama Papers, for example, you can't see it behind my head, but the Paradise Papers, and most recently the Pandora Papers have got up into the millions of documents. And these are completely freeform as well, essentially. So honestly, there's a lot of PDFs. So there's just huge numbers of PDFs that need to go through. A lot of the time they have kind of really basic concerns that you might have day to day when you're just kind of going through email. You know, the PDF doesn't have text because it's just an image. So how do you put text on top of the PDF and all that kind of stuff? But then maybe there's Excel spreadsheets in there. And often, you know, these files will have come kind of essentially copied from the source, and then the files are handed over. And the question is, there's a lot of stories in these files, but how do we as journalists go through all of the files and determine what the stories are? Because at the end of the day, it's completely impractical, even if you've got every journalist in the world, to go through millions of files and read them. It's just not going to happen. So how can you sort of, you know, kind of comb through that in a way to put together what the story is? And of course, you know, technology's got an answer for that. And as I said, you know, back when they were doing the Snowden documents, they had a kind of little version of software that did this. And one of the things that we worked on to first kind of explore how, you know, we could build technology for the news gathering part of this process was a system for exactly that: take a data leak and then search through everything. And the system that we built was called Giant. So that's a screenshot of Giant that you can see up in the top left. And I imagine as kind of computer science students, it's probably relatively intuitive kind of how it works. There's files, there's a search box, you type into the search box, stuff comes back in. In some ways, it's just like a souped up kind of Windows Explorer. But there's some constraints that mean that we have to build kind of software to, you know, work in a way that can't work on just a single laptop. And often one of those constraints is size. So raw, the files might be, you know, multiple terabytes, like the data leaks are getting up to sort of like the 10 terabytes, possibly even hundreds of terabytes. And you can maybe fit it on an external hard drive, but it's quite slow and very difficult to build a system that is kind of quick and responsive in a way that the journalists need. You know, a journalist probably has a list of names that they're interested in. And the first thing they're going to want to do is go to that search box and type in the names. But if then the search that they're doing takes, I don't know, 10 minutes per name, then if they're really interested, they'll probably do it. But it's going to put them off a little bit. And you want them to kind of be exploratory and maybe even a little bit surprised about kind of the connections that they're able to find through the data as they go through it. So Giant, you know, just goes through all of those files and makes it kind of indexable. And actually various organizations have sort of built software systems like this over the kind of intervening years. So I've added some screenshots there of Aleph, which is from the OCCRP, which are the Organized Crime and Corruption Reporting Project, I think, out of Sarajevo. And then there's another shot there from DataShare, which is from the International Consortium of Investigative Journalists. So we'll talk a little bit about how like the back end of these systems work and kind of what makes them fun to work on from a technical point of view. But what was interesting about all of these systems being developed is that you're always doing it, again, in collaboration with the journalists. So there's very basic feedback. You know, I type into this search box and the search is slow, or, you know, the UI kind of falls over or isn't quite as intuitive as I expect. But there's also, you know, really interesting feedback that we started to get around, like, I want to do this thing. So I want to, you know, maybe go through and pull out all of the beneficial owners, for example. So in a lot of these data leaks, there's kind of pro forma documents where there's phrases essentially where they'll say like beneficial owner, and that's where you want to go straight there to avoid having to make quite so many hops around these kind of obscure offshore company structures. So they can do that with searches for sure, but that's something that you learn not by building the technology to kind of do these searches and make them faster, but by actually talking to kind of the users you have and like each one of these tools has gone off in interesting directions based on the conversation with their users. So Aleph, for example, is much more good at kind of what we call structured data. So you can use it to sort of build connections between companies relatively easily and really kind of cross-check between multiple data sets. Giant is quite good at being fast on a new thing that you've got. So it can sort of what we call index or make things searchable while you search on top of it, and generally try to be fairly quick at that. We tried to make it pretty scalable in the back end as well. And data share is kind of walking the line between the two. But in all cases, like, what sort of often made it valuable was the discussions that you were having. So there was a basic kind of architecture that these systems kind of followed, and a basic kind of UI principle that everyone knows from, you know, typing into a Google search box or something like that. But what was as useful was those sort of discoveries we had from speaking to the journalists, as well as actually building the system. But of course, like, you're computer science students, so I'm going to tell you about how it worked because it's kind of fun, and we can dig into a little bit into the back end. And all these systems are relatively similar, but I'll talk, you know, mostly about how Giant worked. But it's analogous for all of them. So here you've got a perfectly accurate diagram of how this ends up working. So in Giant, originally it was designed for that sort of like data leak analysis kind of thing. So you can see that hard drive there, like someone's bought a hard drive of some stuff, and we want to be able to search through it. So we have what we call that kind of ingest pipeline. And honestly, that's just a fancy file copy, because what you want to do at that point is get the files off that media pretty quick, because you might not know how long you have access for that media. And ultimately, you know, you don't know what process the source essentially has gone through to acquire that data. And, you know, they honestly may well have put themselves in harm to get it. So you want to kind of get access to that data pretty quickly. So we then get that data straight into what's called S3. So for those of you who've heard of like Amazon Web Services and sort of the computers that Amazon will sell you in the cloud to run things, as well as just like raw computers, they've also got services. And one of those services is a thing called S3. And you can upload data to it and get data back out. That's what it's good at. It will store data with ridiculous amounts of reliability. So that ingest pipeline is just get data off that as quick as possible and throw it up into S3. And then we'll run it through those additional processes. So we've got what's called that Ingestor Polling. And that's essentially like, find out what this is. Because we know there's going to be terabytes of data, but we don't know what's in it. But we do know from kind of experience maybe what we want to prioritize. So things like emails are really good. Like emails have like sender, who it was sent to, a time, and everything. They can really help you get a feel for the flow of information and essentially the flow of power through the company or the source of the data that you've got. So maybe you want to process those kind of first. You want to expand archives first. So like, you don't want to kind of process all the terabytes of data and then eventually get to that final zip file, which has got all the interesting stuff in it. But you don't know because you spent, you know, the last kind of 3 hours going through C:/Windows System 32, which is always the same stuff every single time. So the phase 2 polar is really there just to kind of pull through and do that initial analysis so that we try and get some information about what is roughly in the dump, because maybe there's some file formats that we don't know, or as I said, you know, kind of focus on those things that we know kind of give initial value. And then the results of that then go into the two databases that we've got. So we gave them kind of fancy names. We called one the manifest and one the index. And the manifest is just like the definition of what we've got. So a lot of the time when things are kind of uploaded from those source drives, it pretty much just reflects the folder structure that you'd see on that disk. So you can filter by the original structure as if you were browsing on the disk, but you don't have access to it. And yeah, like what file type it is. With emails, you can sort of build connections between the two. And it was that building connections that we found quite interesting. And that's what led us to use a database called Neo4j. And Neo4j is a graph database. So rather than, you know, say a traditional relational database like MySQL or Postgres, which ultimately at the end of the day stores data conceptually as rows, Neo4j stores data conceptually as graphs. So this thing is connected to this thing. I don't know, company owner X is connected to company owner Y via a Cayman Island offshore company. It's really good at storing those connections and then letting you query in quite a kind of free-form way what those connections might be. So that's why we built our manifest using Neo4j, because we thought that, we'd be doing a lot of kind of queries on those connections. And then we've got the index. So that's the bit that powers that search that you saw there. And for that, we used Elasticsearch, which at this point is getting towards an industry standard for how to kind of quickly build search features like this. So it gives us a really nice programming interface where we essentially just extract from the document the text, and then we throw it at Elasticsearch. And then Elasticsearch gives us decent search response. Like, it's got out-of-the-box defaults that are quite good for relevancy and all of the kind of things you can tweak to make search really, really good for your particular use case. It gives decent defaults. It's also scalable as well. So in a similar way where we use S3, because we knew we wouldn't run out of storage, we use Elasticsearch because we know we can keep on adding more computers as the number of data sets get bigger, and we can kind of search across all of them. And yeah, that was pretty much how it worked for data leaks. And as it was being used, we sort of realized there was a lot of usage of this that we hadn't anticipated outside of, just kind of like someone brings a hard drive of terabytes worth of stuff. And in particular, people were uploading their own documents to Giant. So journalists would have like PDFs knocking around on their computer. And one of the things Giant could do is it could extract text from a PDF that didn't already have one. Which sounds like magic. At the end of the day, we just used a program called Tesseract, which you can get off the shelf and is pretty good at it. But that's something where if you try and run it on your laptop, you need to be a developer to install it, and then it's a command line to like type in commands. But we just had inadvertently made kind of a web interface where you could like put a PDF into it and get the text back out. And actually that was really powerful. Like, journalists were using that every day. And we sort of realized that in pursuit of building tools for journalists, we built the biggest, most complicated possible tool we could build. And it was quite good at its job. Like, it was great at handling data leaks. But actually, kind of, the newsroom is more than just those once in a year investigations. There's journalism that happens all day, every day. And we'd maybe be missing those use cases that we would have got from, just kind of working with people day to day and sort of understanding like what their problems were outside of just using it to make data accessible that wasn't already there. So we worked to kind of have a think about this. And with that tension between working on the content management system side and then building these cool tools for journalists, it's always a difficult thing to say to your boss, like, we want to go and work on this exciting thing at the expense of working on the thing that keeps the website going. Like, it's a difficult argument for any boss, or difficult question for any boss to say, yeah, absolutely, the website's fine, you can not worry about that. So we ended up kind of founding a brand new team called the Digital Investigations team, now Investigations and Reporting team. And the mandate for that team was look after Giant, because it's doing good stuff, people are using it. But the mandate was to go out there into the newsroom and find out what software needs to be built to help journalists day to day. Like, what are those use cases that are not covered well by existing tooling? And then build it, like, just collaborate with people and build it. So for the rest of the talk, I'll kind of just give you an overview of like the kind of three major projects that we did at the start of that kind of, I guess, entrance into the newsroom. What made them interesting, what made them different to something that was big and heavy like Giant, and kind of what I learned about, collaborating directly with users as a result of building these things. So as I said, to begin with, we went out to the newsroom, and to be honest, we just asked for ideas. We had some people we knew who'd been working there a long time, and they kind of helped us, give us almost the credibility. So we didn't just rock up and say, we're programmers, let's build software changes everything, but more kind of like, we built something that you used, but we didn't think was maybe the number one thing you needed. So what is the number one thing you needed? And that's a difficult question to answer. Like, even if you use something every day, maybe your answer about what features you need will be super specific to what you care about. But nobody gets together in like teams of 30 and says, oh, what do we actually want our software to do? So we were kind of starting that conversation, but coming at it as developers as well. So we had a sense, inherently of what was kind of technically possible. And one of the journalists that we spoke to was a journalist called Sandra Laville, who is focused a lot on kind of environmental reporting. And in particular, she was looking at Facebook advertising, which this was sort of 2018. So right when, sort of online political advertising was, it's still a hot topic, but it was really kind of entering the public consciousness as something that people needed to be aware of. And in this particular case, there were various fossil fuel companies, essentially, who were funding online advertising, but the advertising was presented like it had come from a sort of grassroots organization. So just looking at the adverts, it was difficult to tell who was funding it. It would say it was funded by an organization that sounded, like it had been put together by a group of 14 people, but actually the funding had often come from fossil fuel companies. So the question was, like, can we quantify this? So the story was there. The story was that these groups were being funded, but to how much and what effect was this having? And Facebook at the time had released what they call the Ad Library API. So it's still up there. You can go and look at it. You can essentially search through any kind of sponsored Facebook advert and see data about who it was targeted at. But the way it's changed recently, but the way it was done originally was it was designed for kind of very much needle searches. So you knew you wanted to look for this particular thing. And in a lot of cases, the advertising campaigns were much more general than that. They were targeted multiple people, but also had variations in phrasing, because often you want to test how well a message is received by a particular audience. So we wanted to go through the ad library and sort of more en masse and find out what the effect was. And with our experience on Giant as well, we sort of knew that we could build a bespoke off-the-shelf tool to do this, but it might have worked, but it was probably going to be a bit heavy. And one of the other things that's always important to factor into these kind of system decisions is it was probably going to be quite difficult to change. And what we ended up doing was just using the ad library API that lets you put in search terms, putting in quite general search terms, to the point of literally like putting in fossil fuel as a search term and get out all of the fossil fuel advertising, across America from this API. And then putting it into this tool there that you can see in the screenshot called Kibana. So I mentioned Elasticsearch earlier on. It's really good at search. It's also really, really good at counting things and sort of performing various kind of basic statistics across the data set that you've given it. So we wrote a little script that downloaded all of these ads, put them into Elasticsearch, and then we were able to quantify the spending, because Facebook gives you the spending amounts, although it's in pretty substantial bands. We were able to quantify the spending and the targeting that was being done for these particular adverts. And what was fun about this was not only putting it together, but there was a session that I had with Sandra and David, one of the other journalists on this project, where I put all the data into Kibana. And I knew roughly how to query Kibana. And they knew roughly the sort of things they wanted to find, like maybe some phrases, maybe some things they hadn't seen before. And we just sat there for half an hour, like swimming through the data, where they shout things out, I'd type in queries. And we got some new things that were added to the story. And that was super exciting, because, again, we weren't building technology, not even necessarily for them to use directly, but we were building technology that we were collaborating with them to answer the questions that they had. And this, for us, was really exciting because it met that first criteria that this team had. We were sort of producing things that were evidently being used in the sort of news gathering sense, the news gathering stage. So how do we take that to the next level? Well, if you work in a newspaper, the number one most exciting time is an election. And The Guardian, being historically UK focused, means UK elections are a big deal. And we sort of had the task from, I guess, the editor downwards, that they wanted to monitor online advertising during the last UK election campaign, because it being such a hot topic with, sort of how it played out in America and the potential impact of online advertising and sort of Cambridge Analytica really highlighting what data was previously available. There were kind of two tasks. One was to spot anything interesting, but the other was to kind of quantify what was the online advertising space looking like for political advertising during the UK election, and who was spending how much money, just kind of keep track on it. So we actually kind of formed a mini team. So whereas before I was like working with Sandra and David to kind of help them out, now we formed a team where we also included data journalists. So data journalists, compared to what we were doing, they're out there trying to find the stories in the data. And we were out there trying to find the tools that needed to be built to get to the stories in the data. So this was really exciting to work with them, because we were able to take the ad library scraper that we built, change it so essentially it was running against UK keywords. And then it ran every day. So every morning it would produce using a little kind of, I call it an algorithm, like that's really probably overdoing it compared to what it was just adding things up. But it would produce a report that described the state of UK political advertising that day. And then the journalists would just go through and look for the stories, because you could see what was having the most reach, who was looking at this. You could see who was it targeted at. So was it looked at by, 60% women, 40% men, various kind of categories that were placed in that. And then they could be playful with it. We literally just turned it into a Google sheet. So what was previously really difficult stuff behind this API, where you could sort of type in searches and do it quite laboriously, now we had en masse data that was hardly, big data. There was only about 15,000 rows in it or something, but they could tweak it and start to look at it and find interesting things. And this was where we built a kind of what's known as a scraper, so like a script that you just run kind of periodically to get this data. But it was getting quite hard to maintain. And it was difficult to know that it was maybe it was missing some data, or we weren't really able to verify that the data we were getting back out of it was exactly what we wanted. And it was at this point that Joseph Smith, who was in my team, he previously worked on what was called the Guardian contributions. So if you've ever visited the website and there's a bit that says, since you're here, have you considered giving the Guardian some money? He was on the team who worked for that. And obviously a big thing that they do is in quantifying and kind of verifying their impact. And he'd previously used a tool called Athena for that. And Athena lets you run SQL queries. So again, for those of you who've done kind of databases, that's like select blah, blah, blah from Facebook ads, where this Facebook ad was from the Conservatives, for example. But we could just focus on getting the raw data, and then using SQL, we could tweak the queries and be even more playful than what we could do in the Google Sheets, to really kind of dig down into this analysis, and also make it reproducible. And queries are easier to debug for this particular use case than maybe like a scraper and some procedural code was. And I think kind of the key point about that was, even in and amongst the kind of intense period that is an election in a newsroom, we were, innovating again is a strong word, but we were reassembling tools that we'd already used in different contexts to solve this problem. And by having Joe, who had experience in a totally different part of The Guardian, by working with the data journalists, and by putting that all together, we were able to, not only solve the problem, but actually come up with some really exciting kind of stories. So one that we were able to find was, we found adverts that were being targeted by the Conservative Party in the UK, that were being targeted towards women with a particular message around safety, often sort of describing, that they would put more police on the streets, that they, were going to like really focus on crime and things like that. And then we found variations on the same adverts that were really being targeted towards men, but we're focusing more around entrepreneurship and building a business and making Britain the best place to kind of build your business. And that was an example where we, as developers, found that little mini story, because we sort of understood the flow that journalists were going through in the data we were providing them. So at this point, we weren't making the story, but we were contributing to the story as well. And then that feeds back into it, because then we know exactly the sort of data that people are looking for, the method that they're going through when they analyze this data. And we were making kind of better tools for it as a result. So kind of the final example that I'll give you for like the project that we did in this team is the Queen's Consent project. So again, it's actually back to David, who I've mentioned a few times. He'd spent a lot of time sat in the National Archive, which is something that journalists do. And he was in particular hunting down evidence of use of this very archaic kind of legal principle in the UK that no one had ever heard of, really, certainly I hadn't, called Queen's Consent. So what Queen's Consent is when they go to Parliament, the legislature, to kind of debate the laws that are coming in, the Queen's lawyers will be given advance notice of certain laws and the contents of what those laws could be. And the Queen's lawyers will be given that before it's debated in Parliament. And she essentially says, legally speaking, thumbs up, that's great, I'm fine with that. As a notion, it's quite archaic. I don't think anybody would really debate that. But what David was able to do was go back and find examples of perhaps where this process hadn't been quite so much of a straightforward thumbs up, but maybe where the Queen's lawyers had not explicitly suggested changes to the laws, but certainly, hinted at potential changes that may or may not have been advantageous to the Crown. So David had found that in sort of old school, shoe leather journalism of sitting amongst a whole bunch of papers in some archives until he found it. But what they were looking for to kind of add a bit extra to the story was, again, quantifying the impact of this. Like where the data kind of came in was how many of these bills in Parliament went through this process. So the website for the proceedings of the UK Parliament is called Hansard. Well, not just the website, the actual proceedings is called Hansard. And it's got an amazing search bar, like a really, really good search bar. So you just go on the website and you could literally type in Queen's Consent signified, and then it would give you back every time that had been said in Parliament back to, essentially forever. And that was great, but there were variations on this. So as well as Queen's Consent signified, there's Prince of Wales consent signified. And then there's various kind of ostentatious, slightly flowery variations on this language that David was able to put together into search terms that matched what we expected, but also potentially matched things we didn't expect as well, because you had to look at the combination of where these appeared in the text. So we had, again, that kind of API, if you'll call it an API, you have that search box that you could put your search terms into. But we wanted to analyze that data in a way that was kind of, not a bit more complicated than what you could do from the web interface. And when we were working during the elections with the data journalists, Pamela Duncan had showed us a Chrome extension called Web Scraper. And it's pretty simple. For those of you who've done kind of HTML and CSS, you can use what's called a selector to pull out an element on the page. So I could write a selector to find where it says Church of England National Assembly. I could pull that out as a piece of data. And then when you've got a box for each kind of law, you can do that per box in this Web Scraper extension. But you're not writing code. You're just using a little bit of knowledge of selectors. And you can even kind of point and click and it will generate them for you to pull out all that data. And then you can also automate it to kind of go next through each page of results. Because in the end, there weren't that many pages. I think there were 500 pages of results or something. But you could understand David and Rob, after having sat in the National Archive for however long, weren't really up for clicking next. So we put together that Web Scraper and we ran it. And I can't remember the exact number, but it quantified the number of bills that went through Queen's Consent. So that gave the story kind of a nice kick, and it answered the question, that Rob and David had asked us. But what it also gave them was something they couldn't get from the archives, which was a full list of all of these occurrences. And they went off and looked into various kind of occurrences, and then those spun off into individual stories themselves. So it was an example of where we were working in direct collaboration with them. And then that feedback loop was kind of closed. And they said, oh, okay, well, I can take that and take the results from running this web scraper and turn those into stories as well. And in this case, we really, I think, reached what the purpose of the team was for, which was, it was really helping journalists workflow, but it was also kind of affecting the story in a way, or making it so that stories were uncoverable that we weren't able to do, to the same extent without the technology. And what we realized when we'd kind of done this was that it wasn't by building the most kind of complicated system. I mean, we built Giant, and Giant worked fantastically for what it was designed for. But actually, one of the most kind of effective uses of technology that we found in the team was when we ran a Google Chrome extension and scraped a website. And it sounds kind of so straightforward, but it really kind of drove home to me like the value of kind of walking in your users' shoes, I guess, or not just kind of agreeing with and understanding what your users are trying to do, but actually kind of doing a bit of it with them as you build the software. And you can sort of really then at that point be a bit of a accelerator, I guess, of what they're doing, because it's not just like you care about what they're doing or anything, you understand what they're doing, which I think is super powerful. And like, it wasn't something that I'd ever kind of considered when I was there in my third year of computer science line of looking for a computer science job. I'd never sort of thought about, there's almost kind of, I'm hesitant to say startup-y aspect to that, but I'd never thought of like trying to find an area that wasn't covered yet and work with the users to build the software for it. But that's exactly what had happened, and it was very gratifying to work on. We were all proud of the impact that the team had. But at that point, I felt like maybe I understood a little bit of why Akim turned to me when I got that job in finance and went, "Oh no," because I felt like maybe he sort of understood what I was looking for maybe better than I did at that point. And that's not to, say that like jobs in finance are bad or working on technology is bad, because they're not. But I sort of looked back on that and went, oh yeah, I think I know roughly what he was talking about at the time. And so that's what this talk is really about, which is the working for technology, and pushing the envelope of technology is fun. Everyone, all of my friends will tell you just how boring it gets when I talk to them about the latest web framework that I've been playing with, or, the latest technology that I've been working with. And all of that is fun. But I found that it was almost as much fun, possibly even more fun, to work directly with people to kind of build that software and, walk in their shoes, understand a bit about what was kind of motivating them to get there, do a little bit of it myself, and then, use that to produce kind of even better software as a result, and even more impactful software as a result. Not just impactful for a journalist story, but impactful for users. There were examples when I was working on the content management system where there were features that I built because I've been chatting to someone about how it was blocking their particular workflow, that the CMS couldn't do a particular thing. And that was quite hard to fit within a kind of, I guess, traditional business prioritization framework. But I knew from talking to them that it was beneficial for them and beneficial for lots of people across the building. And that's different from the role of maybe a traditional product manager whose entire job it is to focus on, what's important and on building those stakeholder relationships. But as a developer, I could focus on finding those sort of improvements and that value, maybe in areas that would be difficult for a product manager to maybe find, or certainly to kind of prioritize and fit into their day-to-day work. So I guess my takeaways on like working collaboratively at The Guardian was, understand what your users want to do by learning how to do it. We ended up doing a bit of journalism ourselves, which was quite good fun, but we very obviously weren't journalists. And this was understood, in the newsroom, because at the end of the day, working in journalism can be a bit of a competition. You always want to get your name on the front page and all that kind of stuff. But our success wasn't measured by that. And that was really helpful because we had the support from, the rest of the developers and sort of a technical department. But we were able to work, and do a little bit of that journalism to feed into the software. And often, the biggest impact, as I said, on Queen's consent was from the tiniest web scraper that seemed technically very straightforward, but had an impact of really kind of improving that particular story. And all of this, was only possible because we had our sort of champions to support us. So there were the people in the newsroom who gave us that credibility, but also the sort of engineering management at the end of the day, our actual proper bosses who saw the value in going out there and having this sort of closer relationship with the users that was only possible by us actually kind of working with them. But if we tried to do that on our own, that would have been difficult to justify. But with those kind of that investment, we did really good stuff. And at the end of the day, it was about building kind of smaller things, and then iterating to a better result, which I don't know kind of is the spirit of agile development. But I'd never really seen it sort of or felt it quite as purely as we did on this particular project. So yeah, that's it. I thought it would be interesting just to kind of dive a bit into what we'd worked on and what my kind of personal takeaways were from it. So yeah, thank you for listening to me blast through a selection of interesting stories from a recent career, and I'd love to take any questions if anyone's got any.
Thanks so much, Mike. That was fabulous, as I knew it would be. It's really great to hear all this because it resonates with me in quite an interesting way, because I don't consider myself a software developer. We diverged from in terms of post university, and but as an interdisciplinary researcher myself, I really try to live by that mantra that you're describing. I think, which is sort of learn what your users want by doing it yourselves. Get involved, get your hands dirty, and you can only really understand what they want by essentially understanding their problems firsthand. So it's nice to hear that in a different sector, really. So there's some questions started to come in. I have a few as well, but I'll go for the one that's just come in on YouTube. And I'll just hopefully share it on screen. So the question is, really enjoyed this talk, as did I. I was wondering, is your official job role a software engineering, or is it something more specific? Because you mentioned a lot about data and data scraping. So yeah, I guess this is your role at The Guardian. What was your official job title, I suppose?
Yeah, I mean, so I was a senior software developer, but like the job title aspect of it is quite interesting because, obviously I mentioned the value of having data journalism as a separate discipline to what we were trying to do. So data journalism being finding stories in data rather than, and some of that might be producing the tools to get the data you need to get to the story. But we were focusing mostly on kind of getting the data that then supported all that other journalism. I know that lots of news organizations do try to formalize this a bit. So there's a concept of like a newsroom developer. People like Max Harlow at the Financial Times. I think there's people at the Times in the UK who have that in their title. But it helps to have it sort of nailed down in the job title, that sort of like you are going to be in the newsroom and that's your focus. But we found that what helped us create the environment much more was the sort of understanding and investment from engineering management and I guess the editorial management side as well. The Guardian is kind of smaller than some media organizations, so everybody can wear those hats maybe easier than they can in big organizations. But at the end of the day, it was only by sort of demonstrating to the journalists the value that we could provide on like one project, and really kind of say, we did this and it's really cool, that meant they understood what we were trying to do in a way that just kind of coming in and saying newsroom developer was difficult for them to understand, because, like if you've not worked with software developers, it's quite right, you've got kind of no basis for understanding, like how software developers work. And actually it went both ways as well, which was quite nice. So one thing that's quite a common part of an agile software development process is the idea of a retrospective. So regularly you get together with your team across the disciplines, whether it's developers or, managers, UX, research, all of that stuff. And you just talk about what went well and what didn't go well and come up with actions for improving it. And David, I know, wanted to do one of those meetings as a result of some of the investigations he was doing, which, is a super valuable thing. So that was a case where, again, like some of the working practices could could percolate across regardless of kind of what people's official titles were.
Fabulous. Thanks for that, Mike, and thank you for that question, NJ. I haven't seen any more come in yet, so I'm going to stick one in myself and ask a little bit about this information. So information retrieval, I suppose, is what you could describe some of the work you were doing. So when you were talking about, you essentially have a huge pool of documents that you've indexed in some way, and effectively what you're wanting to do, or at least in general in the information retrieval field, is balance the idea of retrieving everything that is relevant, but also maximizing the proportion of things that you return being relevant, right? So it's the precision recall trade-off. So I sort of wondered what kind of went into that and to trying to optimize precision versus recall, and how did you kind of have your journalist? Did you have your journalists in the loop in that process to kind of get a sense? Can they say to you, actually, you know what, you're returning way too much garbage, or I don't think there's enough actual juicy stuff coming through?
I think there's kind of that we found two kind of challenges with this, which is that it's easy for someone to say, you know, this is returning garbage. So everyone knows you'll do a Google search and then it won't have what you want. And that'll be quite frustrating. But it's very difficult to say what would make it better. It's just as a sort of normal person using a piece of software. And we actually came to a sort of pretty, in hindsight, obvious realization, which is that when people are going through data leaks, they'll often have quite specific searches in mind anyway. So whereas, you know, you may search like Google for dinner recipes for Sunday, and that's a bit general, but something along those lines, you're more likely to be searching a data leak for Michael Barton, who I think is dodgy and is doing this thing. So already people have quite kind of narrow searches when they come into it, and they have people of interest they want to maybe find, or companies of interest they want to find in these data sets. So we didn't actually initially offer exact matching properly. So that was just something we had to kind of build in. And I know the OCCRP have done really good work on like automatically understanding the difference in spelling of Russian names, for example, that can be anglicized in various kind of unusual ways, even beyond the mess that can be created when you turn a document into text automatically. Like you can kind of give that a go. So like in many cases, we can sort of take advantage of the fact that people wanted that exact matching and focus on that. And then what we definitely didn't have was the sort of volume of users that you often need to really kind of help determine true relevancy, because if you're sort of treating it as a black box system and you know that if users can find relevant answers, they'll be able to do this thing quicker. It's hard to do that with investigative journalism compared to, you know, people searching for answers on a website where you can, you know, maybe measure, I don't know, duration on the website or something like that. Some kind of really, you know, you can get metrics in that sense, but you get enough people to get to that significance. Whereas when you've got kind of, you know, even just hundreds of journalists collaborating on a particular project, that's quite a lot harder.
Bro, thank you. Yeah, no, that makes a lot of sense, and actually raises a second question that I had on my list as well, which is a little bit about the open source tools you use, because obviously that's another thing that I very much appreciate is you've used a huge number of open source tools in the work you've done, mostly to kind of essentially package them up into powerful in-house tools. And I just wondered to what extent you were able to just use these out of the box, because if there's one thing I've experienced, especially with tools that are developed using sort of machine learning and things like that, there's a huge problem of generalizability to documents that look a very different way to the data that they were trained on. Now, I don't know a great deal about Tesseract, for example, as a particular example, but did they just work out the box in your experience? Was there anything you had to do to kind of tweak them, or did you have any QA to try and ensure that you were getting stuff out that was half decent? Because sometimes, you know, you could just throw a machine learning model at some data and it doesn't know what it's looking at. So what was your experience with that?
Yeah, we didn't do a lot of that. So like you said, you know, for the OCR, as it's called, extracting text from images or documents that don't already have it, the off-the-shelf models are good. And honestly, like the Google Cloud Vision APIs are even better off the shelf. Like the reason we focused on Tesseract was because we wanted the software to be deployable offline. So if we had something incredibly secret that we weren't comfortable putting in the cloud, we could still do something useful. One example where, like, I think we probably failed to have an opportunity to kind of close that feedback loop and like start bringing in, refinement on machine learning, and not just QA of is it giving me good results, but the idea of why did this give me good results that we can then use to train the model further. Like, I think we probably could have done a bit more of that, but the question again comes back to like, how do you determine the relevance for a particular action that kind of the user wants, which again is kind of easier to do on mass, but with smaller numbers of users and smaller amount of data, it's a bit harder. And on a base level as well, like we probably could have done a bit more training on the OCR. But Tesseract, I mean, it's got models for every language that we needed out of the box, which was helpful. And I think it's still honestly a bit of an unanswered question within the field about kind of how to refine the off-the-shelf machine learning. And as the data leaks potentially get more kind of voluminous, it might be an interesting thing for, if not a research project, but something to kind of focus on, because just kind of building up a big corpus is not the only way to train a machine learning model. And I'm not sure like the other ways of sort of more unsupervised, I guess, at the end of the day, learning, we've not really explored some of the angles we could with that. But of course I don't work there anymore, so maybe they're doing it, but at the time it was maybe a bit of a missed opportunity.
Maybe a project idea or two in there anyway for
future
definitely undergraduate students. Final year students. So I hope they're listening. Thank you for that. So I don't think we had any more questions coming in. I'm going to ask one more with a minute to go, so it's going to be a fairly rapid one. But it's more general and to do with kind of giving some advice, perhaps, to our future computer science graduates. Is whether there's any particular experiences you can draw upon from your undergraduate life that you think has helped you to get to where you are. I know you mentioned, obviously, you did your final year project and things like that. Is there anything in particular you felt, looking back, that was a particularly useful thing that you did, possibly outside of your immediate formal degree studies?
Yeah, I mean, it's got nothing to do with investigative journalism, but I volunteered to be the sort of, I guess, technical person for the university radio station. And one of the things that we needed at the radio station at the time was what's called a playout system. So, like put the song into the equivalent of the digital cassette tape and click play and arrange all of the kind of audio. And being a programmer, I was like, that's straightforward. I can sort of understand how that works, so I'm going to build it. And I did build it. I built it in Visual Basic, which was a bit miserable, but it did work. And people used it to an extent, but it never quite got the sort of adoption that I had hoped and expected it to get. And the reason for that was that even though it worked, it wasn't what people expected. And so everyone else who was sort of, working in the radio station, a lot of them, might have been working towards careers in media, for example. And there are standards for this sort of software in media and for editing audio more generally. And so I was learning a lot from building these systems and diving in, but I think it would have been better for me to extend something that was already there and to use it kind of, in the shoes of how people were using it. But also certainly would have been a lot better for them to then have said, I have experience with this technology. And that's not always the right answer. And certainly like just using a technology for technology's sake is definitely not something to aspire to. But in this case, I think, again, that was maybe somewhere where I didn't quite have the empathy with my users that perhaps I thought I had.
Fabulous. Thank you very much. So yeah, that's another lesson to you always go work for a university radio station or any opportunity to do a bit of programming outside of your regular studies. I think is got to be advantageous for sure.
Yeah, definitely.
So I think that's time for today. So I just wanted to say thank you once again, Michael, for stepping in and giving this talk, which I found thoroughly enjoyable, and I hope everyone else attending did too. That's the end of Monday for Enhancement Week. So thanks to all that came along, and enjoy the talks throughout the rest of the week.
Thanks, have a good week, everyone. Thanks for having me. Cheers.
Bye.
Bye.